Okay, so that's a good start, I would say. So now I will try to continue something we started last year. So hardcore PKI series, anno 2016. So I'll start a little bit by rehearsing what was kind of hardcore last year, and then we go into what I think is hardcore this year. And well, I hope I lose about 50% of you, otherwise it wasn't hardcore enough, right? So what was hardcore? What's hardcore with PKI? I mean, apart from what Johan and Marcus and the guys already said. So this is kind of, last year we had something about incomprehensible APIs. There's ASM1, of course, X509, RSA, elliptic curves. Now we talk about raw public keys as well, related to IoT, which we just heard about. There's integration protocols and some new kids on the block, like blockchain, and IoT again. So a recap from last year. ASM1 and X509. Well, that's hardcore, right? Well, at least it looks hardcore, but well, no, not really anymore. You know, it's we know about ASM1 by now, and if we run into any problems, you know, we have Bouncer Castle and nice toolkits that does it for us. We just have to be able to understand the ASM1 simple notation. So nah, not too hardcore. How about RC and elliptic curves then? Well, actually in the last year or two, even elliptic curves have become more or less every man's lunch. So, I mean, of course, protecting the private key is actually harder than ever. There's more breaches and more attacks on the crypto and protocols and implementations than ever. But the algorithms themselves, we have nice toolkits for that as well. So we also talked about architectures last year. So there's actually a bunch of different architecture. You can have 2 to 3 level hierarchies, OCSP responders, validation servers, registration authorities, etc. But well, actually today it's more or less converging into offline root CA, online issuing CAs, some validation authorities. Not too hardcore anymore. We know how to do that. You all know how to do that. So then we come into more what I feel is hardcore today, which is more, okay, how does it all fit together? So we saw previous as well. We have users and servers. We have edge devices. We have gateways. Everyone wants to do auto-enrollment. You have to automate things. Identity and access management, mobility, and the TLS with a lot of 2 and 3 and 4 level acronyms, etc. So actually piecing this all together, then it's starting to get a little bit hardcore, I think. So today, at least what we see as pretty hardcore is architecting an end-to-end solution for users and devices, and incorporating both PKI as a service, on premises, integrating everything. It's a lot of stuff, and you can't get everything from a single vendor. Otherwise, that's the kind of, if you have a problem piecing it all together yourself, you go and ask IBM, can you build it for me? And today, the answer is more or less no. You will have a pretty hard time. Maybe you can find someone who says they can do it, but if they really can do it, that's another question. So there's a lot of layers to take into consideration. I'm just looking to see so I can see my own clock down here. There's a lot of layers, and actually there's more layers than ever been before, I would say, just to actually piecing the theory together. And then you also have to deploy it and integrate it in practice. So let's dig a little bit deeper into this. I'm going to use the kind of Gartner lingo again, as well as Chris did. So we have the edge with smart and stupid devices. We have the platform, which does a lot of things. Now I see the red things are slightly skewed. So the platform does device authentication, data persistence, device management, access management, actually has to process the data, and of course have to do key management, which is where PKI comes in. And the enterprise actually have to make use of it in some way for the applications that actually does something. There's analytics, there's user management, etc. And well, you can draw something pretty similar regarding, let's say, classic PKI use cases as EID and e-passports. I mean, there you have kind of on the edge, you have your EID cards and passports. You have some platform which does actually manufacturing of these cards and verification. And then you have enterprise or government who actually puts it into use, be it for digital signatures to sign tax returns or other things, actually doing crossing borders, etc. So it's a similar concept, but there's a lot of different stuff, and everything needs more and more security, which makes it harder. But we'll dig even deeper. So integrating it is starting to become hardcore. It wasn't so hard a couple of years ago. It's harder now, I would say. We have a lot of different, now I'm talking from a PKI perspective. We have several different protocols and APIs in order to integrate. We have classic ones as SCEP, who has been around for ages, will be replaced by EST, maybe, in the future. We have CMP, also been around for ages, but have actually picked up in the last recent years in popularity. And of course, we have some different types of web services, SOAP, which we have done for ages, but now everyone is talking about REST, of course. And that's not even all. I mean, there's actually a whole list. If you look at a survey that Admir sent out a link about, we have a list of many, many more different protocols just to choose from. And there pops up new use cases for PKI everywhere. And here really the old saying comes in that standards are really good, everyone should have one, because new use cases that pops up, well, they of course build on old standards, but they had to add their own flavor. So there's XMPP, there's mobile, there's of course users, there's new types of passports and EIDs, there's ADAS, etc. And yeah, everyone adds their touch of flavor. So there's a lot of new naming concepts, subject DN, there's new alternative names, it's just exploding. There's new extensions, everyone needs their own extensions. It used to be only Microsoft that did their own private extensions, 1, 2 started with a couple, then nowadays it's like 20 or something. But other use cases also needs their own extensions nowadays. So actually, understanding your use cases is one thing, but also being compliant not only with a kind of say technology perspective, actually getting the right extensions in the right way with the right fields filled, but also process and audit compliant. I mean, you have Etsy audits, you have web trust audits, and a whole bunch of others as well. Probably each industry has their own audits. So actually be able to be compliant so you don't get publicly flamed in forums and you hear yells of being revoked, etc. That's, I would say, trickier than ever. So let's dig deeper. You're still with me, right? Good. And why is it tricky? Because the devil is in the details, of course. So let's first dig into some protocol details, and then we have a couple of use case specific details as well. So I don't know how many are using CMP here, but I bet there's a bunch of you, exactly. And it's been around for ages, and it's pretty good. I like it. Class historically used for integration with card and token management systems. Where the token management system acts as an RA, which has authority to issue tokens, which means register users, etc. It's also starting to be used for device bootstrap and enrollment. In particular, LTE or 3GPP has actually profiled the CMP pretty good for LTE eNode Bs. It handles both RSA and elliptic curves. It's very flexible. It handles full lifecycle support, I would say, from initial bootstrapping of a device, if you have a certificate from a factory, from a vendor, up to revocation or expiration of the device. But, of course, you have, well, not a couple of hundred actually for just CMP, but there's a bunch of different options to choose from in order to configure CMP. Of course, these are EGBCA screenshots, how to configure CMP in different ways. And no, you're not supposed to be able to read this. So you have to figure out which options to configure in order to configure it for your use case, because all the token management, LTE nodes, etc., you have to configure it differently. So this one was almost supposed to be readable, but I'll go into some of the details. So we have two kind of major modes in CMP, which we call operational modes, which is client mode and RA mode. So RA mode, as it sounds, is when you have the client is actually a registration authority. So it tells the CA what to issue, and the CA more or less does what the RA says. Of course, still enforcing some policies, etc., profiles, so the RA can't do anything it wants. And the other mode is client mode, where it's more the CA or EGBCA is the authority, and the client is just more or less a stupid client who says, can I give me my certificate that you decide how it looks like? Okay. And of course, different devices or users or RAs have different ways of authentication, and CMP support a whole bunch of them, of course. One is it's called HMAC here. So that's when there's some shared secret-based authentication. That was the most common some time ago. But you can also authenticate the CMP client with client certificates. And you can even configure it with some, one is called Reg Token PVD, which is something used for client mode, which is more, say, classic PKCS10 style authentication when the client sends also a shared secret. And there's even some hackish parts where you use part of the DM as a shared secret. Of course, you need to be able to, when using certificate authentication, you need to distinguish which are the authorized CAs in order to do enrollment, etc. Just to make it more flexible, which CMP is, you have something called RA Verify, proof of possession. That's when the RA actually generates the keys on behalf of a user, but the user, well, let's say I got it wrong there. The RA generates the request, certificate request on behalf of the user, but the user still possesses the private key. So the RA can't actually sign the requests for proof of possession with the client's private key. So the CA has to trust the RA that it has done the needed checks. So you can enable and disable that because, let's say, in some use cases, you actually want to require strict proof of possession checking. You may want to allow automatic key update, or you may want to not allow automatic key update. You may, in some use cases, you actually you keep one private key, but you renew the certificate year and year again. In other use cases, you want to force the clients to generate a new private key. So you want to be able to have checks to not allow reuse of the same private key, right? And then this is, well, a nice one, I think, which is called use vendor certificate mode. And that's for the bootstrapping case. If you have manufactured devices in a factory, the factory can put certificates, private key and certificates on the device on the production line. And then when you actually want to take it in use in your facility, you use the, factory inserted private key and certificate to authenticate the first bootstrap into your network. But you only want to allow this for the first bootstrap. You don't want to allow this for continuous use actually in your network, only for the bootstrap process. To use the device in your network, it needs a certificate from you, of course, because only you should be able to decide which devices should be allowed in your network, not anyone who buys something on town. So that's when you have some external certificate authority which the manufacturer uses in their factory, which then you can use to bootstrap the device to get the real certificate from you. That one is more or less specified by the 3GPP for 4G networks. It's nice. So you can see use cases which use a pretty big chunk of different combinations of this. SCEP as well, very classic, traditionally used very much for integration with mobile device management and also device enrollment. Any Cisco firewall or router has for ages been able to use SCEP for certificate enrollment for VPN or whatever. Even iPhones use SCEP to get your certificate. The reason why it's being replaced is that the standard doesn't support ECC. Well, you could have actually upgraded the standard to make it support ECC, but it has a couple of different, strange things in it as well. So it's also, well, you can use it for a lot of things. Slightly less flexible than, or a lot less flexible than CMP. Somewhat limited the lifecycle support. You can still enroll and renew. It has one good, interesting thing for very, long-term lived systems. It has protocol support to support CA rollover. If your CA lives for 10 years, but your devices actually need a new certificate after 11 years, then there's actually a new CA in place with new private key, etc. So then the device automatically has to be able to get the new CA certificate and trust it, of course. It has to be done securely. And get a new certificate from the new CA and just continue as nothing happened. So that's, it's pretty nice. Not too trivial, but it works, actually. Some SCEP details. Actually, a lot of less options in SCEP. But as well, it also has what we call RA mode and CA mode, which is, for some reason we call it RA and CA. In CMP, we call it RA and client, but it's pretty much the same. So in client mode, we don't trust the client for anything. In RA mode, we trust the RA to actually know what it's doing. As I mentioned, the CA rollover use case is pretty nice. First, when you want to roll over a CA, you issue a new CA certificate with a new private key, of course, which is not yet valid. So you can, when the old CA has 2 months left to live, you issue a new CA certificate and a new private key for that CA, which starts to be valid in 2 months. And then within that time span, before the old CA expires, the client gets the new, not yet valid CA certificate. And the new CA certificate is then signed by the old one, so the client can trust that the new CA certificate is something that should be trusted because it still trusts the old CA. And before the old CA expires, the client can also get a new client certificate, which it doesn't start to use yet, but it sits on it for a while until the old one expires, and then it starts using the new one. And of course, all those validity periods kind of are thoughtfully considered, so they match and everything continues without interruptions. So this is actually, well, if you run a software-defined network with thousands of nodes and network nodes, etc., everything must be secure, use a lot of VPN, TLS connections, etc., and it just have to work year out and year in. SOAP. We have the SOAP protocol for ages in EDBCA. It's very, I would say, full-featured, or at least has a lot of features. Full lifecycle management of certificates, of course, but you can also automate configurations with it a lot. So a lot of people use it to build kind of totally custom front ends, which can grab the configuration from the CA in order to present it to the users in a way that EDBCA doesn't do. Managing roles, renewing CAs, etc., etc. Uses client certificates, of course, for authentication. And for those, of course, using client certificates for configuration means that it also uses whatever this client certificate matches to for access control. And for those of you who have used EDBCA and dug into the access control, you know this, say, the dreaded access control configuration pages where we have kind of like a couple of hundred or at least 100 different access rules that you can configure fine-grained exactly what the SOAP or web service client is allowed to do. There is some kind of simplified configuration, so you at least can configure a more limited user and a more capable RA, etc. But in a lot of use cases, you have to actually fine-tune a bit, and then you really need to keep your tongue right in order to know what end-entity profile rules view end-entity does. And next, which we have seen a lot of talk about, REST. So we don't have a REST API yet. We're thinking about it, and it's going to come sooner or later. To start with, what is definitely required is lifecycle management, because that's how you would integrate it with something like identity and access management system, where it will need, in order to manage the users which are managed by identity and access management, it will get certificates, revoke certificates, renew certificates, etc., on behalf of the users. And of course, being able to find certificates as well. Good so far? Excellent. So then, so that was some protocol details. And actually, I mean, the suite of protocols to be used are growing constantly. So we had for a number of years, we basically had a SOAP-based web service, we had SCEP, we had CMP. It covered more or less all the requirements. Now we need REST API, we have EST, there's a couple of other ones popping up on the horizon as well. So the whole protocol suite is expanding quite rapidly nowadays. And that has, of course, to do with the new use cases. Since PKI more or less is used for everything today, in order to, well, all use cases want PKI to integrate as transparently or non-obtrusive as possible. And in order to do that, in order to provide a user with a good user experience, well, you need to tweak in a few things to make it fit very nicely into the use case. So there's popping up all the time. Recently, there's XMPP needs specific stuff. There's something called Subject Identification Method, or SIM, which is, I thought it was a SIM card at first, but it's not. It does have nothing to do with the SIM card. There's register ID used for Open Trust Protocol, I think. There's Kerberos. Microsoft is coming up with new things, different IoT standards will invent new things. And in the, say, old school world with EID and e-passport, that's also evolving faster than ever. So now we have ICAO comes up with new things like name change extensions, document types. ADAS comes up with new things, new QC statement, new distinguished name components. Of course, the TLS world is don't want to be left out here. They also invent new things because they are kind of upping the security efforts and the bars for security. And I think, well, we need some new components as well in order to identify or how to say trustworthily bind certificates to companies, etc. So they come up with the jurisdiction, country, and things like that. Well, it does look easy when you create your new standard. It looks easy. I just add a new field, and it is pretty easy. But then when you want to put it into a product, it quickly grows. I mean, this is just a small list of new use cases. And when you implement it in a product, it quickly grows to, okay, there's 24 more configuration options or things to choose from. And then when you want to use your product and you say, okay, well, I have the XMPP use case. I want TLS certificates. I'm going to issue ADAS certificates. And yeah, I have my Microsoft environment and my Kerberos environment. And your vision of configuration option just grows exponentially. And that's where the hardcore comes in. And there's one thing is to technically, I would say, get it, because then, of course, we get a lot of questions from different customers who, well, okay, we need these options, and how do we configure it in EDBCA, and how should we configure it? And I mean, some of you are super good at your use cases, so you know exactly. You just say, well, we want this, and this. Can we get it? And we say, yeah, okay, maybe you have to tweak this, and we can help you with a custom extension or this and that. Other customers, actually, they have, how do you say, requirements to set up an ADAS compliant trust center or something, but they don't have necessarily your expertise. So they ask us, okay, what values should we use? And of course, from our point, it's easy to say, well, technically, ADAS requires this, and this, or EVTLS, you should have this and this, and here are the reference to the specification. But it doesn't necessarily mean that the end user knows what to put in there. And the more and more CS you have to combine different use cases into one. It used to be slightly simpler, I would say. Most people had a couple of use cases. Nowadays, everyone's use cases are growing. So I have a couple of quick examples of that. And also how to show how you actually have to be on top, because all these specifications and standards evolve. So, and if you're involved in 10 of them, you have to be on top and follow all 10 of them. Otherwise, you will be publicly flamed because you're still using a common name in your EVTLS certificates, although it's deprecated or something like that. So this is, I mean, it used to be that in SSL certificates, nowadays TLS, the common name field was the place to look for the domain name. It's been deprecated for quite some time in RFC 3280 in the good simple old days. But now it's deprecated, discouraged, but not prohibited. So you shouldn't use the common name field anymore. You should, of course, only use the alt name field. But this, well, at the same pace as the threat level and say external threats to different use cases increase, also the say domain experts up their level of innovation to counter the threats. And the CAB Forum is no exception. They have, released constantly evolving standards in order to be more secure, more trustworthy, etc. So sometimes it's hard to keep pace. And if you at the same time are issuing ICAO certificates for passports, well, then you have to be on top of the ICAO specifications, which have come up with new releases a couple of times a year. And one thing, when we started with ICAO, there was no such thing as a document type extension. And that was, I think, like in 2006-07 or something, when countries signing CA first started. This didn't exist. Now you have to have it. And well, yeah, we can read the ASM1. But still, the more new things you put in, the bigger risk is that, well, there's going to be a bug somewhere. And well, it recently turned out we had a small bug in the encoding of this ASM1 structure in EDBCA. Of course, we can fix it, or there's workarounds to do it. But, well, if you add 10 new things, probably one of them will have some initial bugs until it's ironed out and when it's old and stable. PKI used to be this old, mature technology that, it had been working the same way for 10 years, so nothing what could ever break. Now it's new things everywhere, so some things will break. The same with ADAS, Qualified Certificate Statement. So this is the ASM1. You have to study it a little bit to figure out, okay, you can't put all these things in. If you read the specification a little bit deeper, you say, okay, they recommend that these fields be put in. And then when you want to actually use it, you figure out, okay, for different types of ID cards or persons, etc., you need different configurations. So you have to come up with a list, okay, we're going to issue qualified certificates, and we need 5 different types, and all with slightly different flags, etc. And I would say, since the specification is rather new, not it's not the whole world who has had time to digest it in detail. Yeah, so that's hardcore. Modeling the end-to-end architecture and workflow for specific use cases, and while you're doing so, not violate any standard or audit requirements, so you become publicly flamed, because that's also kind of more common these days. If you do some mistake, well, someone will probably notice. And there's hundreds, if not almost thousands, different knobs to turn in order to get it right. And, well, I think, if you have a lot of use cases, you will make some mistakes. That's just how it is. That was hardcore PKI. Now I have a couple of minutes left for something where I'm slightly out of my depth. So everyone is asking us about blockchains, so we have to study it a bit. So this is the part where, say, Ryan can leave the room, or other people who know much more about blockchain than I do. So if you think I'm full of it, that's okay. Yeah.
You need it if you want VC funding these days. If you don't have blockchain on your business plan, there is not very much chance.
Yeah, I saw that there were a slide that there was, like in the last 3 years, there had been $1.4 billion in funding for blockchain-related inventions, etc. So anyhow, yeah, we have to study it as well. So why do we want to study blockchain? Well, it's pretty interesting new technology, and since it kind of touches, there's some identity-related things with blockchains, etc. So it's bound to have some bearing on us sooner or later. Not today, maybe, but in a ranging from not too distant future to a very distant future. Who knows? So what do we think about blockchains? Well, there are some good things about blockchains. And actually going back. So blockchains, I would say, is not only one thing, right? It's a kind of a range of slightly different technologies. But one thing in common is that they are supposed to have decentralized control where no one owns control of the network. Unless you don't want to, of course. You can run your own blockchain, right? And then you will control it, no doubt. But it should be immutable. Written data is tamper resistant. Very attractive feature as well for PKI, because things like audit logs, I mean, they must be tamper resistant, and revocation data, whatever. PKI has always been have a history of tamper resistance. Ability to create and transfer assets without reliance on a central entity. We'll see. The bad thing about, let's say, classic blockchains, Bitcoin blockchains at least, is pretty low throughput, high latency, not so high capacity, and very limited querying capabilities. I read one academic paper which tried to actually use, instead of a classic database which we use, a blockchain for a Bitcoin type blockchain for the PKI. And well, it worked, of course. They got it to work, but it was like, maybe 10-second latency to issue a certificate, etc. So it's not something you want in your usually classic PKI. So what do I think are possibilities for blockchain and PKI? Well, first you can have, well, of course, the first option is that, well, you could put your PKI in the blockchain, where you can use the blockchain more or less as a kind of distributed database. Sounds quite attractive. But you can also have PKI as a complement to blockchain applications, where if you want to have, say, the nice features of Bitcoin blockchain or of Bitcoin and such blockchains is that they want some, or they provide some sort of privacy, etc. But in many use cases, well, you can't have privacy. So then you might want to complement a blockchain application with a parallel system for strong authentication or non-anonymous things. Let's try first with PKI in a blockchain and why it might be interesting. Well, PKI, I would say, classically, it's inherently transactional and deterministic, and consistency is crucial, right? Consider qualified certification, qualified certificates for legally binding document signing. Yeah, when you issue a certificate to someone, it better be recorded, and if you revoke it, it's going to show up as revoked. It's not going to show up as, yeah, I think it's revoked, all right? But perhaps using techniques to overcome the standard blockchain limitations like low latency, etc., and capacity, well, it could be an interesting way to achieve some sort of distributed hyperscale PKI where you can have distributed all across the world, and where you are not totally relying on all nodes being up in order to use it, etc. But in a highly distributed system, you probably will end up having some sort of probabilistic instead of deterministic view of things. So it would certainly not be suitable for a classic PKI like EID, where you need to be sure, so to say. And when you revoke something, it must be shown up as revoked within, I mean, something from 1 second to 24 hours. But similar to this picture then, if it's probabilistic, you will say, okay, I know that it's probably revoked, maybe with 99.999% probability, etc. And so it may be, if you exclude classic use cases such as EID, it may be suitable for things like IoT applications. So if you issue 100 million certificates to, I don't know, your cable modems, etc., yeah, it's probably okay if you're pretty damn sure that it's out there and not revoked, etc. It's good enough, and it's very cost efficient. And just found some claims that with various blockchain techniques, you can actually have low latency, high capacity querying features, etc. So if this is a classic Bitcoin blockchain, and this is a classic PKI, so missing some parts, well, there's some claim that some hash chain based combination with big databases could do something about it. Combining blockchains and PKI, well, say traditional blockchain transactions are somewhat anonymous, but in a, say, at least a regulated financial world, there is no such thing as an anonymous transaction. And the blockchain doesn't actually handle non-payment communication, such as, okay, you're the merchant, I'm the consumer, and can you give me an invoice and I will pay it? Yeah, but then of course I can do the payment on the blockchain, but not the other stuff. And you have to be legally compliant if you're, say, at least a merchant in Sweden. So there are, of course, people who are thinking about this and trying to come up with protocols such as BIP75 is one example of a payment protocol which takes the say, non-blockchain part of the communication between a merchant and a consumer, and to actually get binding identities so you can fulfill regulations, etc. Payments on the blockchain, identification, and things on the side. A layer of identity separation from public blockchain data. So that was my short rambling of possibilities for PKI on blockchain technology. So I put some reading, some stuff that you can read as well as an end slide or suggested things. That was it. Well, if anyone has some short questions, we have time for that. Then.
Sorry again. Is this already on your roadmap somewhere, blockchain, to do anything with the blockchain, or is this at the moment just...
Well, actually, we are planning to make a first, set out for a master thesis work to experiment or investigate and possibly do some proof of concept depending on what they find out. So we're set out to start to do some more serious research in the area. Okay, then.
How about you said before something about limitations. I think there is also unresolved issue with the blockchain, 51% attacks and similar attacks.
Yeah.
Bitcoin hasn't solved that yet. How smaller altcoins are going to solve that is an even bigger question.
Yeah, I guess maybe it's relevant for PKI, maybe not. So it's hard to see, say, a PKI system being kind of a publicly shared thing. More likely to be an organizational. If you run your cloud with 100 million users, you may want to run your PKI in a blockchain, but you're going to control 100% of the computing resources anyhow, but it has some other attractive aspects which makes you want to look into that. Okay.